Okay, this is concept number 3, which is solving and graphing linear inequalities. So it's very similar to what we've done in the past towards the beginning of the year where we were graphing equations, except for now it's an inequality sign. So it's going, instead of it being y equals, it's going to either be y less than, y greater than, less than or equal to, or greater than or equal to. It's going to have an inequality sign instead of an equal sign. The initial graphing portion is exactly the same as we would normally graph. It has to be in slope-intercept form, which remember is y equals mx plus b. So it has to still be in that same form in order to graph. Then you graph it exactly the same. You're going to start at the y-intercept, plot that point, and then use your slope, which is rise over run, to plot the rest of your points. Then, because it's an inequality, we take it one step further and you either have to shade above or below the line. Okay? And that will be determined by the inequality sign that is given. So if we look at this first example, and this to the left here is just a set of steps to follow when you're graphing these. So your first step, like I said, is to make sure that it's in slope-intercept form. Okay, so there are times where your first step is going to be to rearrange the initial equation. Sometimes it's given to you in slope-intercept form, like in this first example, it's given to you in y equals mx plus b. And there are times that it's not, and you have to rearrange it first. Okay, so step 1 is a sometimes step. Okay, there are times where you can just disregard step 1, sometimes you can't. And step number 2 then. Once it's in slope-intercept form, you're going to graph y equals 3x plus 4. Okay, so, or whatever the equation is. In this case, it's graphing that actual equation. Now, when you go to graph it, with the equations, it was always we just drew a solid line. Not the case with inequality signs. And it's the same concept as when we put them on a number line and we either used an open or a closed circle. Same basic concept. If you're dealing with just a less than or just a greater than sign, it's a dotted line. Right? If you're dealing with less than or equal to or greater than or equal to, so the ones that have the equal to sign underneath, you're going to actually, then you're going to draw the solid line. Right? So you two different types of line depending on which inequality symbol that you are working with. Once you graph it and you choose the type of line, this is where it adds in an additional step. Okay, where because it's an inequality, we have to decide, are all of my answers going to be below the line or are all of our answers going to be above the line? In order to figure that out, you use a test point. Okay? You can pick any point on this graph that does not fall on the line. Okay? So it can't be a point that falls directly on the line, but you could pick any other point anywhere in the graph. Okay, and plug it into your equation and see if you get a true or a false statement. Now, the easiest point to plug in is 0, 0. Okay? The only time you cannot use 0, 0 is if your line goes straight through the origin, because then 0, 0 is on the line. But 0, 0 is typically the easiest to plug in because things cancel. It's quick work and a quick check to see where you should shade. Okay. So in this first example, y is less than negative 3x plus 4. Step 1 is done for us. It's in slope-intercept form, so we don't need to rearrange. So I can go straight to step 2 of graphing the y equals negative 3x plus 4. So you go to positive 4 on your y-axis. Remember, we start with the y-intercept of a positive 4 and plot that point. So on the vertical axis, you go to positive 4. Then our slope is a negative 3. Now remember, we make that a fraction by putting it over a 1. Rise over run. So the negative 3 tells me to go down 3, and it's over a positive 1, which is to the right 1. So I drop from my initial point of 4, I drop down 3, and move to the right 1, and draw another point. And then I can keep going. Drop down 3, right 1, draw a point, drop down 3, right 1. Okay, we can also go in the complete opposite direction. Instead of going down and to the right, we can go up 3 and to the left 1 to draw an additional point. Okay, so you should always be going in both directions to graph this so that you have points from one edge of the graph to the other. Now, once we have those points on there, when we go to connect them, you have to be careful and decide if it's a dotted line or if it's a solid line. In this case, because my inequality sign was just a less than, it's going to be the dotted line. It's not solid. Okay, which means, remember, solid means that points that are actually on this line could be a solution. In this case, because it's an open point, if you're thinking of it as the number lines, or it's a dotted line, nothing that falls directly on this line is an actual solution. Now, last part is part 3. We're going to use a test point. Okay, and like I said, 0, 0 is typically the easiest, and in this case I can use it because it's not on my line. So I plug in 0 for x and 0 for y. Okay, and we're going to test to see if I get a true or a false statement. So I have 0 is less than -3 times 0 plus 4. Well, -3 times 0 cancels out, it gives me 0. So I really have 0 is less than 4. I have to decide, is that true or is that false? Is 0 really less than 4? And yes, it is. It's true. That means if I get a true statement, I'm going to shade over top of my test point. Well, my test point was right here, which is below this line, so I'm going to shade everything below the line, right? Everything where 0, 0 actually is. All right, second example. 2x plus y is greater than or equal to -5. So again, going through the steps. Step number 1, we're going to have to do here. Okay? This is not in slope-intercept form, so you have to rearrange it first. In order to rearrange it, I need y by itself. So I'm going to move this 2x to the other side by subtracting it. So I get a -2x minus 5 on the right-hand side. Now this is in slope-intercept form. Now I have my y by itself, and everything else, my x term and my constant term, are all on the right-hand side. So we start by graphing. Remember, y-intercept is at -5. So on my y-axis, I drop down to -5 and plot my first point. Then from there, we use our slope. Well, our slope is a -2. Again, we make that a fraction by putting it over a 1. So a -2 means I drop down 2, and a +1 in the denominator means I move to the right 1. And I can keep going. Drop down 2, right 1. I can also go the opposite direction. Up 2, left 1. Up 2, left 1, and you keep going until you run out of room on your graph. Now, once you have the points plotted, you have to check your line. This was initially a greater than or equal to sign, which means it gets a solid line. So when I connect these dots, it is a solid line. Now, final step is to decide, where do I shade? Okay, remember, this line really cuts my graph into 2 regions. Okay, I have all of these points down here underneath of my line, or I have all of these points up here above my line. So I'm going to test 0, 0 and see, are these my true answers, or are all of my true answers on the other side of the line? So I test 0, 0. Now, in this case, because we had to rearrange it, you can plug it into either the very original or the one that you rearranged. It doesn't matter which one you plug it back into, so it's completely up to you. We show the work here for both of them. So in the original, I would have 2 times 0 plus 0 is greater than or equal to -5. 0 is actually bigger than or equal to -5. So my test point tested true, which means everything else that's on the same side of this line as the test point is also a solution. So any of these points above the line could be a solution to this inequality. Okay? All right, 2 more examples. Again, these both down here need rearranged. So you subtract the 3x to the other side. -y is less than or equal to -3x minus 1. Now, here's where you've got to be really careful. This is a negative y, so you still have one more step. You have to make sure that you remember to carry that negative down with this y. Because now you need to divide everything by a -1. Which, with an inequality, remember when we divide by a negative, you have to flip that inequality sign. So your new inequality becomes y is greater than or equal to positive 3x plus 1. Then you graph it just like normal. Go to positive 1, plot a point for your y-intercept. Then your slope is a positive 3, so I go up 3 to the right 1, up 3 to the right 1, you keep going. Also, you can go the opposite direction, down 3 and left 1. Again, it's a solid line for this equation because it was greater than or equal to. So I have a solid line, and then again, pick a test point. 0, 0 will work. I do not go directly through the origin here, so 0, 0 still works as a test point. Plug it in. 0 is greater than or equal to 1 when you plug it in, which is not true. 0 is not bigger than 1. So your test point was false. So that means that everything else on this side of the line is false, which means you shade on the opposite side of the line from your test point. Remember, the test point is checking to see, do these solutions actually work? We're trying to shade where they actually work at. So if my test point was false, then I have to shade the other side of the line. So everything in this case above the line is your solution. Same thing happens in this last example. You're going to subtract the 2x to the other side. Again, you end up with a -3y here, so you have to divide everything by a -3, which flips your inequality sign and gives you a positive 2/3 x minus 2. That's the equation you want to graph. So you go to -2 on your y-axis, and then you use your slope. Up 2, right 3, up 2, right 3, and you keep going with your slope of 2/3. This is going to be a dotted line because this was just a less than symbol. Okay? It does not have the equal to sign underneath of it, so it's got to be a dotted line. Then, once you have it graphed, pick your test point. Again, 0, 0 will work here. Okay? So you can use that as a test point. Plug it in. We get 0 is less than -2, okay? Which is not true. 0 is not smaller than -2. 0 is bigger. So my test point was false, which means I shade on the other side of my line. So I'm shading underneath of the line this time. Okay, that's it for your notes. This is concept number 3, which is solving and graphing linear inequalities.